Hello dear students, welcome to the lecture series of Object-Oriented Programming. In this lecture, we are going to see creational patterns and the types of creational patterns. At the end of this lecture, you will be able to introduce creational design pattern with its different types. Creational design pattern focuses on the creation process of the objects. They help to make a system independent of how its objects are created, composed, and represented. Creational patterns for the classes use inheritance to vary the class that is instantiated, that means whose object is going to be created. The creational patterns for the objects delegate the instantiation to another objects. There are different examples, different patterns which are of creational design patterns, that is factory method, singleton, abstract factory method, then builder design pattern and the prototype design pattern. Let us see singleton pattern. The singleton design pattern ensures a class has only one instance and provide a global point of access to it. It ensures a class has only one instance, that means a class has only one object. When it is used when we must ensure that only one instance of a class is created, when the instance must be available throughout the code, and in the multi-threading environment when the multiple threads must access the same resources through the same singleton object. The singleton patterns access the resources in the shared mode. They are used to implement the different patterns such as factories, abstract factories, builder, and prototype. Let us take the example of a singleton pattern. The office of the President of the United States is a singleton. The United States Constitution specifies the mean by which a president is elected, limits the term of office, and defines the order of succession. As a result, there can be at most one active president at any time, at the given time. Regardless of the personal identity of the active president, the title, the President of the United States, is a global point of access that identifies the person in the office. Now here, the President of United States is the single object of that respective class. What will happen when we create a multiple objects of a class? A class is like a blueprint that specifies what the type can do, what an object can do. An object is basically a block of memory which has been allocated to the blueprint to the class. A program may create many objects for the same class. The objects are stored in the heap memory location. When we create an object of a class, a memory is allocated in the random access memory. Please observe the diagram. When we create the different objects for the single class, what will happen? Let us see. The random access memory consists of the different cells, and when as the random access memory is volatile and the information stored will be lost when we close the program or when any power loss. The random access memory is made up of cells. Each cell has its own unique address where exactly the object will be stored. So, when we create a multiple object for the same class, multiple memory will be allocated to the same object but with the different cell addresses in the RAM. So, the memory will be wasted. Let us see the next pattern, that is factory method. It creates the objects without exposing the instantiation, that is the process of creating the object logic to the client. It defines an interface for creating an object but let the derived class decide which class to instantiate or whose object shall be created. When it is used? It is used when a framework delegates the creation of objects derived from a common superclass to the factory. When we need flexibility in adding the new types of objects that must be created by the class, at that time this factory method is used. It It provides the abstraction for the object creation. Then the next method is builder method. It defines an instance for creating an object, but it lets the subclasses decide which class to instantiate, that is whose object shall be created. The builder class builds a complex object using the simple object. A builder class builds the final object step by step. The builder is independent of other objects. It allows the final control over the construction process. When it is used when the creation algorithm of a complex object is independent from the parts that actually compose the object, and when the system needs to allow different representations for the objects that are being built. So in that case, that builder object is created. I hope you have understood the creational pattern and the three types of creational patterns. We'll meet you in the next lecture. Thank you. Happy learning.